Hello, my name is Alexia Fernandes. I'm a master in sports training, swimming teacher in Clube Fluvial Portuense, and a collaborator in Faculty of Sport of University of Porto, and I will talk about index of coordination. Arm coordination is an important characteristic of swimmers' expertise, since swimming is a cyclic sport and an upper limb cycle is composed by propulsive and non-propulsive phases that are organized differently depending on several variables that influence its performance. In that sense, index of coordination was created for quantifying arm coordination for alternative techniques. The index of coordination measures the coordination of upper limbs with precise quantification of the lag time between the start of propulsion by one upper limb and the end of propulsion by the other. And so, what is the interest of this? It is a great tool for quantifying the interlimbs coordination in swimming, since it is based on the quantification of the upper limb phases durations, and so it gives us information about its organization. Consequently, it allows to assess the modifications of arm coordination with increasing velocity, since fastest swimmers are characterized by higher index of coordination values for equivalent swim paces, being proposed as a parameter to assess skill level. However, high values of index of coordination are not automatically linked with high velocities, but should be associated with indicators of propulsive efficiency, such as stroke length or intracyclic velocity variations, to determine whether the coordination is well adapted to the swim velocity. Index of coordination also let us know the technical skill of the swimmers, once high-level swimmers are more capable to modify the different phases of the upper limb cycle. However, the three-dimensional movements of the upper limbs are well known. In fact, the upper limbs phases in a cycle are entry, down sweep, in sweep, up sweep, and recovery, that comes from the propulsive dynamics that argues that the swimmer does not push water to move forward, but executes vertical and diagonal movements. This index does not take into consideration these three-dimensional movements of the upper limbs, but the phases entry and catch, pull, push, and recovery, linked only to the action-reaction law of Newton. For the calculation of index of coordination, first it is needed to record each upper limb movement for the identification of its actions. Then it is calculated the mean duration of each phase and the duration of the total upper limb cycle. Pull and push phases are considered the propulsive actions, and entry, catch, and recovery the non-propulsive ones, and should be summed for the last calculation. The lag time will be the time between the beginning of propulsion in the first right upper limb cycle and the end of propulsion in the first left upper limb cycle, and between the beginning of propulsion in the left second upper limb cycle and the end of propulsion in the first right upper limb cycle. The results are easy to interpret. If index of coordination is equal to 0, we have a coordination of opposition, which means that one upper limb begins the pull phase when the other is finishing the push phase, so does not exist any time between the propulsive phases and the propulsion is continuous. If index of coordination is less than 0, we have catch-up coordination. That means that a lag time takes place between the propulsive phases of the two upper limbs. This is the typical rest swimming in which the swimmer glides during one complete upper limb cycle. If index of coordination is higher than 0, the coordination is superposition, in which occurs an overlapping the propulsive phases proper of high swimming velocities. Literature about index of coordination is quite extensive, and many studies correlated index of coordination with other variables such as sex, swimming velocities, race distances, skill level, and swimming constraints. Being known that higher active drag is characteristic of high velocities that leads to higher index of coordination. Contrarily, at lower velocities, swimmers tend to adopt lower index of coordination. According to velocity, elite men have a greater catch-up coordination than elite women, and these differences seem to be the result of the anthropometric and muscular power differences between genders. Index of coordination increases with shorter events due to the highest velocities. Regarding skill level, despite elite and beginner swimmers present the same index of coordination at a given velocity, high-level swimmers are more capable to modify the different phases of the upper limb cycle, and index of coordination in elite swimmers increases more than in beginner swimmers. The dynamical approach to motor coordination provides an interesting account for explaining changes and stability of coordination modes in cyclical tasks. Preferential coordination modes seem to emerge from the interplay of constraints. Arm coordination seems to emerge from an interplay of constraints which is summed up by the stroke rate. It could be hypothesized that the higher the stroke rate values, the lower the number of options to swim. Indeed, environmental properties change in relation to velocity of the upper limb and could block the swimmer in a pattern whether stroke rate is high. These data suggest that expert coordination is rather linked to the capacity to swim with high stroke rate than to a general motor program. The majority of the studies resorts to front crawl swimming, although there are also studies in backstroke. If we want to study coordination in simultaneous techniques, we don't use index of coordination but total time gap. This quantifies the coordination between upper and lower limbs, and the logic is the same but with different phases of the upper and lower limbs. So, concluding the topic, index of coordination provides indication of the upper limbs organization, which allows us to better analyze our swimmer's technique in different situations. We also saw that arm coordination is correlated with several variables related to swimming performance, such as sex, skill level, swimming velocity, race distance, and swimming constraints. So it is a useful tool for swimmers and coaches to enhance performance. Thank you for your attention and interest in this topic. I hope this information is useful and that allows you to have more control over your swimmer's training and performance. See you!